Hello friends, today we are going to do theorem on areas of similar triangles. So the theorem is the ratio of the areas of similar triangle is equal to the ratio of the squares on their corresponding sides. See, in the questions only, what are the types of triangle? The ratio of similar triangle, that means you need two similar triangles and the ratio of their area is equal to the ratio of the squares on their corresponding sides. So you need two triangle, similar triangle. Okay, take this triangle. Name it ABC. The other triangle you can name it at XYZ, PQR, anything. Take another triangle. Name it P, Q, R. Now we have two triangles, both are similar. So what is the meaning of similar triangles? What is the properties of similar triangles? Their corresponding sides are, the ratio of their corresponding sides are equal. That means the corresponding sides of similar triangles are in proportion, that we have already learned. So now you have to prove what is given. What is given? Two triangles are given and they are similar. So you can write triangle ABC is similar to triangle PQR. So this is given. So what you have to prove now? To prove, if two triangles are given, two similar triangles are given, what you have to prove according to question? You need to prove that area of triangle ABC divided by area of triangle PQR equals to, what you have to prove now? The ratio of this, the ratio of the area of this similar triangle is equal to the ratio of the squares on their corresponding sides. Now what are the corresponding sides? The corresponding sides of AB is PQ. So but according to theorem we need to put their squares are equal, right? The square. So AB square upon, you can write PQ square equals to, what is another one? BC, the corresponding side is QR. So you have to prove BC square divided by QR square equals to, now the corresponding side of AC is PR. AC square divided by PR square. You need to prove this. According to theorem, you need to prove this. These are all the corresponding sides. Now, constructions, what you can do, from A you draw perpendicular on BC, from A draw perpendicular on BC. Similarly from P draw perpendicular on QR. You can name it D, you can name it S. Now what you have added in the diagram you need to write here in constructions. Right. AD perpendicular to BC and PS perpendicular to QR are drawn respectively. Are drawn. Now see in the diagram, AD is perpendicular to BC, similarly PS is perpendicular to QR is drawn. Now to prove how you start proving your theorem. Now proof, starting since what is similar according to your theorem, what is similar? ABC, triangle ABC. Since triangle ABC is similar to triangle PQR, so when these two triangles are similar, definitely their corresponding sides, the ratio of their corresponding sides are equal. So you can write AB. Therefore, AB by PQ. AB by PQ is equal to BC by QR is equal to AC by PR. That this when two triangles are similar, their corresponding sides, their ratio of their corresponding sides are equal. That we have proved already. So according to your theorem, triangle, these two triangles are similar. So we can write AB by their corresponding sides, their ratio of their corresponding sides are equal. AB by PQ is equal to BC by QR is equal to AC by PR. So mark it as equation number 1. This is your equation number 1. Now, not only their ratio of corresponding sides are equal, but their corresponding angles are also equal. So what are the corresponding angles of corresponding angles of angle B? Corresponding angle, when these two triangles are similar, their corresponding angles are equal. So the corresponding angles of this angle is this angle. So what you can write here? Angle ABD equals to angle this angle ABC is equal to angle angle PQR. You can write, therefore, angle ABD, you can write the reason here, corresponding parts of similar triangles. Angle ABD is equal to angle, this one, angle P, sorry, you can write D or you can go up to C. This angle PQR. Angle PQR. The reason is, what is the reason again? Comma. What is also there? Angle. This angle and this angle is equal. Similarly, this angle and this angle are also equal. So you can write it as, this is equation number 2, and the reason is corresponding parts of similar triangles that we have already proved in earlier classes. That whenever two triangles are similar, the ratio of their corresponding sides are equal, as well as their corresponding angles are equal. Now, as I have told you, this angle ABD, what is the corresponding angles? Angle PQR. Similarly, the corresponding angle, this one. This angle is also corresponding angle ACB is equal to angle PQR. You can write it. So equation 1 and equation 2 we have formed. Now let's delete the question, erase the theorem. Now check this triangle. Take these two triangles. From here take triangle ADB. From here take triangle BSQ. In triangles ADB, and triangle PSQ. In triangle ADB and PSQ. So first thing what we know is 90 degree, 90 degree. This angle is 90 degree. Angle ADB is 90 degree. Similarly, this angle PSQ is 90 degree. Why 90 degree? According to constructions, this AD is drawn perpendicular on this BC. That means this is perpendicular means 90 degree. So similarly, PS is drawn perpendicular on QR, meaning this angle is 90 degree. So, and another one, we have already proved that this angle and this angle are equal. So what we can write? This angle angle ABD is equal to angle ABD is equal to angle, this angle PQS, angle PQS. Reason why these two angles are equal? Reason is already from 2. We already proved. From 2 we already proved that these corresponding angles are equal. Angle B and angle Q. So you can write from 2. From equation 2. Now Now from equation 2, another one. In this two triangle, this angle is 90 degree, this angle is 90 degree. So you can write angle ADB. Angle ADB is equal to this angle, angle PSQ. Angle PSQ. Why? Why they are equal? Both are 90 degree. And why 90 degree? I already told you this AD and PS are perpendiculars on BC and QR respectively, according to our constructions. Now from the postulate, angle, since here you see in these two triangles, two of their corresponding angles are equal, then definitely through angle postulate, what we can say, these two triangles are similar. So therefore, triangle ADB is similar to triangle PSQ. Angle postulate. From angle postulate, these two triangles are similar. Again, when two triangles are similar, their corresponding sides are the ratio of their corresponding sides are equal. So therefore, in this two triangle ADB and PSQ, what are their corresponding sides? So their ratios are equal. So what you can write? Therefore, AD upon, you can write AD also, it doesn't matter. AB upon, now what is the corresponding sides of AB? PQ is equal to, and DB by, what is the corresponding, DB, BD, it doesn't matter. So DB, the correspondings of BD or DB, what is it here? SQ or QS? SQ is equal to, and what is the third sides? Third corresponding sides? AD by PS. And the reason is corresponding parts of similar triangles. Since these two triangles are similar, we can write here the ratio of their corresponding sides are equal. So this is your equation number 3. So we have got equation number 1, equation number 2 and equation number 3. So what we can write now from equation number 1, from equation number 1 and 3. Say equation number 1, what is in equation number 1? AB by PQ is equal to BC by QR is equal to AC by PR. And equation number 3, AB by PQ, same AB by PQ, DB by SQ is equal to AD by PS. So AB by PQ, both the side is equal to these two parts and these two parts. But what we need is from equation number 1 and equation number 3, you take the necessary part. That means what part you need the most here? AD by PS. So you can write now from equation 1 and 3. From equation 1 and equation 3. In equation, what is there in equation 1? AB by PQ is equal to BC by QR is equal to, when you ignore this DB by SQ and AC by PR, you can write AD by PS. Why? Because AD by PS is also equal to AB by PQ. So you can write AD by PS. So this is the result we get is from equation number 1 and equation number 3. So you mark this as equation number 4. Now we got our equation number 4, and now we need to find the ratio of the areas of triangles. Therefore, you know the formula of area of triangle, right? Area of a triangle, what is the formula? Half into base into height. So applying this formula, so what you need to prove here? Now let's go to the end part of the theorem. Area of triangle ABC divided by area of triangle PQR is equal to, the formula goes same, half base into height, half into, what is the base? Now see here, area of triangle ABC. Area of triangle ABC, what is the base here? What is the base here? BC is the base, right? BC is the base where the perpendicular is standing. BC into height. Now what is the height? The perpendicular we have drawn on the base is the height. So what is the height here? AD. AD. Divided by, similarly, area of triangle PQR. Formula is half base into half into, what is the base in triangle PQR? QR is the base. Into height. What is the height? The perpendicular drawn, that is PS. So here, your half and your half will be cancelled. So what is remained? Area of triangle ABC. Area of triangle ABC divided by area of triangle PQR equals to, now BC into AD, QR into PS. You can write BC upon QR into AD by PS. AD upon PS. Now what you can write? Or area of triangle ABC divided by area of triangle PQR equals to, now BC by QR, keep it as it is, BC by QR into, now AD by PS, according to equation number 4, AD by PS, you can replace AD upon PS by BC upon QR. Equation 4, AD upon PS is also equivalent to AB by PQ, also equivalent to BC by QR. So now you can replace AD by PS here AD by PS by BC upon QR. So in place of this AD upon PS, you can write BC upon QR. Now, or area of triangle ABC upon area of triangle PQR equals to BC into BC square, similar QR into QR square. Now, one ratio of square of one corresponding side is equal to this area. Now since ABC and PQ are similar, the ratio of corresponding sides are equal. So if you put square on both the ratios of corresponding sides, then your theorem is proved. So BC upon QR, BC upon QR is also one pair of corresponding sides, which is equivalent to AB by PQ, also which is equivalent to AC by PR. So when you put squares on each ratio of corresponding sides, your theorem is proved. So you can write from this, therefore your theorem is proved. Therefore, area of triangle ABC divided by area of triangle PQR is equal to, what we need to prove? AB square upon PQ square is equal to BC square upon QR square equals to AC square upon PR square. Hence proved. QED. So thank you friends. Thank you.